all supposed to have a calculator? You didn't bring yours? Please do not ask me later to explain this to you because I'm not going to. You're supposed to have it with you every single day. So, I'm in my book on page 296. And I'm going to do a problem out of the book. Here is what they have given me. I'm doing number 20. Number 20. So they've given me a table of values. If you have your book, that's great. If you don't, then you'll just have to figure out what I'm doing here. They give me a table of values. And I am going to write the equation of the exponential given this table of values. Now, that is exactly what you just did on the quiz. So I need all the quizzes turned in now. All the quizzes turned in. Okay, so I need all the quizzes turned in. Anything else that comes in is be graded. So get them turned in. Okay, now, on the quiz, you had to write the equation of the exponential, and that's what's happening here. You're going to write the equation of the exponential. But on the quiz, I gave you 2 points, and that was all. What have you been given here? This is a table of values. So this is a point, and this is a point, and this is a point. So they gave you 5 points. You don't need all 5. You get to pick whichever ones you want. Well, you don't really, because I already told you which one you have to use. Which one you have to use? The one with the 0. So what does this point tell me? I'm going to use it. What does it tell me?
A is 5.
It tells me A is negative 5.8. So already I know that my equation is negative 5.8 b to the x because I picked the point that has a 0. Now they gave me a whole bunch of other points, and you will get the right answer no matter which one of those you need. You just need one more, so you get to pick. I'm going to give you a suggestion. Anybody have any idea what the easiest one might be? They're all going to give us the right answer, so really there isn't any bad point to pick, but which one's going to be the easiest? Judah? The one with the 1, bingo. Because what do I do with my x coordinate? Where does it show up? It's the power. So isn't this going to be a whole lot easier if I pick that point right there, plug in my y and my x? What makes that so easy? I don't have to square root it or cube root it or do anything funky. Isn't this just the same as b? So how am I going to get my b value? I'm just going to divide. So I could do it without a calculator, but it's a whole lot easier with a calculator. So 4.64 divided by 5.8, I get 0.8. So my equation is negative 5.8 times 0.8 to the x. Y equals that. Now, it started out looking a lot different, but do you see it's the same thing you've been doing? Pick the point with a 0, and then if you have a 1 option, pick it, because it's always going to be the easiest option. Now, if you don't happen to have a 1, then you'll have to deal with another point. What's the next one I said? There's one more that is from the book. Number 22. Now, number 22 is a little different, because instead of giving you a chart, they gave you a picture. And said, okay, we have an exponential that looks like this. And you're going to write the equation of it. That's the information they gave you. So it's exactly like the quiz. Didn't they give you 2 points just like I did? And one of them has a 0. So I can already say y equals 3 b to the x. Would you agree from that point right there? Now this is where it gets a little tricky, because now I'm going to plug that point in. So 1.49 equals 3b to the 4th.
We divide by 3 this time.
So the first thing we're going to do is divide by 3. So 1.49 divided by 3. Now, that's the difference between the calculator part and the no calculator part. On the no calculator part, you had to do division, but it was always nice, right? So it's always going to be nice if I'm not going to let you use a calculator. But if you have a calculator, I can have you divide anything. All right, so I got 0.497. I'm going to actually say 0.4967 equals b to the 4th. Everybody okay with that? Now, when I was doing this by hand, and on the quiz it was things like b to the 4th equals 16, what did we do? We 4-throughed both sides, right? And the 4 through 16 was 2, so everything was perfect. Well, this is exactly the same kind of equation, so I have to 4-through it. The problem is, how do I find the 4th root of 0.4967? I use my calculator. So here's how that works. I want you to, first of all, I want you just to explore something. If you press the math button, you just press your math button, which is in the first column, one of the options is this. Do you see that option in the list? Okay, that's the button we're going to use, okay? But first, we have to tell the calculator what that is. So clear out of there, go back to your home screen. We want the 4th root, so press 4, and then go get that button. Oops, go get that button. This one right here in the math menu. This is in the math menu. And then type in 0.4967.
We got 0.8395.
And you got b equals 0.8395. So one more time. If I have to take, obviously I have a square root button. So if it's a square root, I just use my square root button. But if it's any other root, I can use this button right here. But when you use this button, you have to put this number in first. So if you're doing a 6th root, you would type 6, and then that button, and then the number that you're doing. Okay? So what's my answer here now? I was writing this equation, so A was 3, and then B is 0.8395. No, yeah, to the x power. And the instructions are going to tell you how to round. I will, who's sending you with candy?
Mrs. Bavanka.
The instructions will tell you how to round, but I'll give you a heads up. When exponentials are involved, round off error is huge. So we try to carry as many decimal places as we can reasonably do. So try to hang on to 3 or 4 decimal places so that we don't have as much round off error. Okay? All right. So next, we're still keep using our calculators. Next, we're going to write an exponential function to describe some other kinds of problems. Now, let's back up a minute because we haven't used this vocabulary in this context. This point right here, when I am writing my equation, y equals a times b to the x, this point right here always gives me a, right? And what do we call a? What is the name for a? It is called the initial value. So in the home or in the note problems here, where it says the initial value is 4, doesn't that mean I'm going to start in with 4 times something to the x? Now, it says I am increasing. That would indicate growth, right? By 11%. So what goes in here? 1.11, bingo. What does this number represent? Growth of 11%. So when it tells you you're growing 11%, that's it. That's the answer to A. That's all there is to it. Now what is B? What would be the answer to B? Y equals 0.36 times I'm increasing 22%.
1.22.
1.22.
Is it always going to be 1 point something?
It is. Well, unless you're increasing like 200% or something, then it is bigger than that. But normally, yes. Yes. All right, C. Now watch it. C is a decrease. Okay, just lay it there. C is a decrease. So we're going to start with 147, and then what am I going to multiply, guys, if I am decreasing 10%?
90%.
0.90 or 0.9. You are allowed to just put 0.9. You don't have to put 0.90. Doesn't matter. All right, next. Initial value 20.8. Please don't forget there's an X on that. Don't forget the X when you write your equation. What's happening here? We are decreasing 4.5%. We are decreasing 4.5. So remember, you have a calculator for all these, so you can figure that out. What is it? Yep, 0.955. Remember, how much less than 1? Well, you're 4.5%. So that's let's say 100 minus 4.5. 100% minus 4.5. So that's how we got 95.5. The initial value is 16/3. And we're decreasing 42%.
58.
So 0.58 to the X. So simple. So now we're going to do a problem. The population of Keltville was 123,000 in the year 2000. It decreases 2.5% each year. What is its population in 2010?
Is the initial 123,000?
So we're going to write our equation to be 123,000. Now we're decreasing 2.5%. Don't get confused. What if we were decreasing 2%? 98. What if we were decreasing 3%? 97. So we're right in the middle. So what is it? 0.975. Yep. To the X. There's your equation. Now, how do you think we might get an answer to the problem? Well, we're not going to plug in 2010. We're going to plug in 10 because we're going from the year 2000 to the year 2010, which is how many steps down are we taking? 10. So we're going to simply put a 10 right here. We're going to type that in our calculator. Now, when you type it in, if you type it exactly the way we wrote it, you will get the right answer. So if you type 12300 parentheses, wait, 12330, sorry, 12300 parentheses 0.975, close the parentheses. To raise to the 10th, you have a button like this. Everybody see that button? It is right under my clear here in the first column. Hit that button to the 10th power. What'd you come up with? 95,489. Now, I'm not doing the point whatever thing because what does this number stand for? Population. So I'm going to round it off to the nearest person. Does that make sense to you? It doesn't make any sense to say 0.365 people. So just round it off either up or down to the closest one. All right, well, that wasn't bad. The population of Trigville was 9876. It increases 12% a year. What is its population in 2013? All right, so what's our equation look like? Y equals what?
9876.
9876. I tried to give you numbers that are easy to type in. What's my ratio? 1.12. Now, does everybody understand why that's 1.12? We're increasing 12% to the x. Now, that's the general equation, but we want specifically to go from 2005 to 2013. So this isn't going to be an x, it's going to be an 8. We'll type it in on our calculator. 9876 parentheses, 1.12 parentheses, raised to the 8th power. Remember, this little button right here is how we raise to powers on our calculator. You get 24,453.
Yeah.
Everybody okay with that? All right, so that was easy. That was easy. Everybody's got that okay. Exponential equations look like this, and they can help us find all kinds of answers to all kinds of problems. Unfortunately, exponential equations, exponential functions can cause us issues too. Let me think of a good example. If I said to you, 9 is 3 to what power? You would be able to figure that out, wouldn't you?
Yeah.
What is the answer? What is that?
Second.
It's 2, right? No issues there. Or if you had something like 8 is 2 to what power? That would be a problem. You would say, well, it's 3, 2 to the 3rd. The issues come in when I ask you questions like this. And those questions come up all the time in the real life population type problems that we have to do. The only way to solve a problem like this is to use logarithms. So before we jump in and do that, because your teachers from last year told me you had not done that. You haven't solved these yet. If you were in college prep last year, you did not solve equations like that. We're going to do that. But before we do that, we got to do a little background work. How do we handle logarithms? Well, they're not hard at all.
Do we just press the log button?
Well, if we're using our calculator. Now, the calculator has limitations. We'll talk about this later, but it's a log base 10 or a log base E. This is a log base 5, okay? So we're gonna figure out what this is without our calculator, but it's easy. We don't need a calculator. Here is what you need to know. Of all the things, I'm gonna go out on a limb here. Of all the things your teachers have told you today, the single most important thing you have heard today, all day long, except maybe in theology class, you heard something really important. The rest of the time, the most important thing you've heard today is this. In order to solve that problem, in order to figure out what does this equal, we rewrite it like this. 5 to the x equals 5. We call it loop-de-loo. 5 to the x equals 5. So what is the answer to that problem? If 5 to the x equals 5, x must equal 1.
I thought we did that last year.
You did this last year.
Okay.
Log base 4 of 16. What does it equal? 4 to the x equals 16. 4 to the x equals 16. See how my hand's moving in that circular? We call it loop-de-loo. So 4 to the x equals 16. So the answer to that problem is 2. What in the world is this? Just when you thought maybe you were getting the hang of it, I throw this in. What is that? Do you know? It's a different kind of logarithm. ln is log base e. E is called, it's named for Leonard Euler. I know this looks like Euler. Please don't say Euler. That makes you sound kind of silly. It's Leonard Euler. It's Euler's constant. And it's like pi. It is approximately 2.718. Someday, if we have time, I'll show you where E came from. The E is derived. Just like pi is the circumference to the diameter of a circle, E is derived. But Euler is the first one to derive it and write about it. It's very important in mathematics. It's got its own button on your calculator. I mean, it's a big, big deal. Ln is the symbol for log base E. So when I'm doing an ln problem, I'm going to rewrite it. So instead of ln e cubed, I'm going to write log base E, e cubed. I want to know, what does that equal?
Doesn't the e's cancel?
If I do a loop-de-loo on this, e to the x equals e cubed.
That's just x cubed.
So x equals 3. Every time you see an ln,
It's log.
I want you to write it, or think of it at least, as log base E. And then you can do your loop-de-loo, so e to the x equals e cubed. So x equals 3. I want you to notice something. Corey kind of picked up on this already. This was the original problem, right? Look what the answer turned out to be.
3.
It just equaled 3. I wonder what ln e to the 5th would equal. 5. If you can remember that, you can save yourself some time. That's true all the time. Ln e to a power is just the power.
So like on problems like number 6, would we just go ahead and like write one, like 1/3, or should we just like...
Well, it's not going to be 1/3. We'll get to that one in a minute, Max. You're thinking along the right lines, but that one's a little bit tricky. It's not going to be 1/3. You are going to be able to just write something, but you have to rethink that just a bit. Let's do a couple more here, and we'll get to that one tomorrow. The log of 1,000. Well, this is another tricky
A log of
one.
1,000?
What's missing? The base.
Base.
Log automatically means base 10. On your calculator, you have an log button. Log means base 10. It's understood base 10.
So is that 100?
No.
X is 100?
10 to the x is 1,000. 10 times itself, how many times gives you 1,000?
2.
2?
3.
3?
3.
10 times 10 times 10 is 1,000. So x is 3. The answer is 3.
Hello, this is Mr. Kowalski. Before we end the day here with Dr. Greer, I just wanted to make a quick announcement. More than anything, I actually wanted to say thank you to our students. You guys were awesome during yesterday's assembly. The participation was great. Tom had great things to say about you. The comment cards were fantastic. So I did want to let you know that our winner